Hi, in this particular video we're going to be looking at roughly about grade 5. It's going to give you the opportunity to practice some of the skills that you need for GCSE. I hope it's useful to you. If you're not sure about anything, always post a comment. I'll always come back to you. I look forward to seeing you inside the video.
Hi, in this video we're going to be aiming at roughly grade 5. Don't worry too much about the D, it just means that A, B and C are available to you on 3-minute maths. Okay, so please do stop the video, have a go at each of these questions. So the first one is we've got a value of 6x squared equals 384, find the value of x. So the first thing I'm going to do is I'm going to divide 384 by 6 and I'm actually going to get 64. Now again, you might choose to do this differently. It is a non-calculator paper. Okay, so please do have a go at showing each of these calculations. So what we now know is that x squared equals 64. If I divide, or if I square root both sides, I'm going to get that x equals 8, and that would be the answer to the first question. Okay, the second one is a 3 marker. This is very, very common for a lot of GCSE non-calculator papers. So the first thing I'm going to do is I'm going to draw a factor tree for 84. Now I always do these in exactly the same way, in that I'm looking really to produce a kind of a hockey stick type of look, a bit like that. So hopefully you can see that what I've got then is it allows me to more easily see each of the factors as I'm working through. So I'm going to do exactly the same with 120. I always divide by 2 first, and that's going to give me 60. And basically I keep on dividing by 2 until I get to the point where I just can't anymore. So now I've got 15. Now 15 is divisible by 3 and 5, and both of those are prime factors. Now what this allows me to do then is to draw a Venn diagram. Now these are very common for these kind of questions. It's just sort of easier to do it like this, where this is all the factors of 84 in the left circle and all the factors of 120 in the right circle. So if I look now at my factor trees, it's fairly easy for me then to be able to look at the ones which are common to both by just reading across. And you can see here that 2, 2 and 3 are actually common to both 84 and 120, which means that in 84 I've got 7 left, and in 120 I've got 2 and 5 left. So if I want to work out the LCM, or the lowest common multiple, it's basically the multiplication of all of those factors together. So LCM is going to equal to the middle ones, which are actually the HCF, but 2 times 2 times 3, and then I've got the multiplication of 7, which is the one that's remaining in 84, and then also 2 and 5 for the ones that are remaining in 120. So it's a non-calculator, so you would need to work that out. I kind of worked it out mentally as it's the same as 120 times 7, and that's going to give me then 840, which is the answer to question number 2. Okay, hopefully that's all right for you. If you're not sure about any of these, always add a comment. I'll always come back to you, and there are other playlists that you can have a look at as well. So let's look at question number 3. A team of row workers can resurface 5/6 of a kilometre of road each day. How many days will it take to resurface a road of length 30? So basically we're saying of how many lots of 5/6 are there in 30, and the way we'd write that is 30 divided by 5/6, and then really it's a case of performing that calculation. Now effectively I've got 30, which is the same as saying 30 over 1 as a fraction, so I could write that as 30 over 1, and then it's multiply and flip. Okay, now you could, if you wanted to calculate 30 times 6, which is 180, and then divide that by 5. That works perfectly well if you want to. I tend to, if I can, do a little bit of reduction before I start. So I've noticed this 5 will reduce or will divide into 36 times. So actually the answer to this question is going to be 6 times 6, which is 36, divided by 1, or in other words 36 days for the road workers to actually complete that particular task. Okay, hopefully that's all right for you. Let's move on then to question number 2. Now, at first glance, I think question number 4 could be treated, if you wanted, as standard form. However, it might be easier to kind of write it as a fraction. So at the top, I've actually got 4 zeros and then 3 5, and at the bottom, I've got 3 zeros and then 7. So if I wanted to make the bottom a whole number, what I would do is I would move the decimal point 4 places. So 1, 2, 3, 4. However, I've got to then multiply or move the decimal point 4 places for the numerator as well. So if I do that, I've got 1, 2, 3, 4. It's going to end up as 0.35. Now I'm actually okay with that, because that's exactly the same as saying 7 into 0.35, which is 0.05, which is actually the answer to this particular question. Okay, again, as I have mentioned before, you might do your calculations in a slightly different way, and that's perfectly fine to do that. It's no problems at all. Similarly with question number 5, now I'm actually going to use a formula. This is a grade 5 type question, so I would assume that you would know, or at least you've come across the formula, a half a plus b multiplied by h, which is the formula for the area of a trapezium. Now, some people might write this as a plus b over 2 multiplied by h, and that's perfectly fine as well. For me personally, I tend to prefer to write it as this, where a is going to be rounded to one significant figure, because we are looking at the estimate of a field. So 49.1, I'm going to make that 50. The part, or B if you like, I'm going to make that 70, and then the height, I'm going to make that 30. So it does make my calculation an awful lot easier, because A is going to be 50, B is going to be 70, and then H is going to be 30. Now that means then that 50 plus 70 is 120. 120 times a half is going to be 60, and then 60 multiplied by 30 is going to be 1800 meters squared, and that would be the answer to that question. And again, perfectly happy with your calculations if you choose to do it differently. With it being grade 5, I've assumed that you would use the formula, but you could theoretically break this into 3 separate, they call them compound shapes, so you could have A, B and C, and work each of those separately and then add them all together. And again, that's perfectly fine to do that if you prefer. Okay, so is your answer an overestimate or an underestimate? Well, actually it's an overestimate. Now the reason that is because effectively I've rounded up except for the height, which I've rounded down slightly. Okay, so I'd write that as an overestimate. And then if I wanted to put some kind of additional sort of sentence in there, I would put as rounded up. Okay, and then I could put except 30.2, which is rounded down slightly. Okay. Hopefully that's okay for you. These are usually 1 mark type questions, so providing you've got a reasonable answer to that, you should get the 1 mark for that. Okay, so let's move on then to question number 6, A and B. So this again, it's actually a standard form question, but because we're adding or subtracting in part A and then part B, we need to write these out as the actual numbers. So 4.6 times 10 to the 3 is the same as saying 4600. And I'm going to add that to 6.7 times 10 to the power of 5. So remember that we've moved the decimal point 5 places, which means I'm going to have 4 zeros. Now you'll notice I'm writing this backwards because it means then that I can keep everything in the right place, and I'm going to end up, when I add that together, as 674600. However, it does say give your answers in standard form. So if you notice that standard form, always the first number is between 1 and 9. So I need to put my decimal point actually here, which means I've moved it 1, 2, 3, 4, 5 places. So my actual answer will be 6.74. 6.746 times 10 to the power of 5, and that would be the answer to that particular one. Okay, hopefully that's all right for you. Let's move on then to part B, which we're going to approach in exactly the same way. We've got 9.8 times 10 to the 6, which basically means that the decimal point has actually moved 6 places, which means I've got 98 and then 5 zeros, 1 2 3 4 5. Afterwards I'm going to take away 5.1 times 10 to the 4, which is going to be 1 2 3 zeros and 5 1 in there. And when I take one away from the other, I'm going to get 9 7 4 9 0 0 0. Okay, and again I need to put that in standard form, so my decimal point needs to be here. So that's moved 1 2 3 4 5 6. So that's going to be 9.749 times 10 to the power of 6, and that would be the answer to question number 6. Okay, hopefully this is okay for you. If you're not sure about anything, always add a comment below. I'll always come back to you. Please do stop the video, have a go at each of these questions. These are good solid questions for GCSE revision. Okay, so write down 2 over 11 as a recurring decimal. Basically 2 over 11 is exactly the same as saying how many 11s are there in 2 wholes. Now it's going to be a decimal, so therefore I'm going to add a few zeros in here, but basically it's just simply long division. That's going to give me 11 is 2 is 0. Pass the 2 on, that's going to give me 1, and I've got a remainder then of 9, which is going to be 8, and then a remainder of 2, which is going to be 1, and a remainder of 9, which is going to be 8, and so it goes on. So actually a recurring decimal for 2 over 11 is going to be equal to 0.18 with 2 little dots at the top there, which basically means it's recurring. Okay, hopefully that's all right, not too bad for you. So we're about halfway through now. We're probably a little bit more than halfway through. We're about 2/3 of the way through. There's actually only 10 questions on this particular worksheet, so it should give you fairly focused, good quality revision. Okay, so work out the area of the sector in the circle radius of 12 centimeters shown. Give your answer in terms of pi. So that's actually quite nice for us, because it means then we don't have too much calculation to do, and because it's non-calculator, that'll work for us. So the area, well, you know the area of a circle is pi r squared. Okay, you need to remember these formulas every single time. However, we haven't got a whole circle, we've got a part of one. We've got a sector of a circle, and the sector we've got is oops, sorry, I did that wrong. The sector that we've got is going to be equal to 60 out of 360 degrees. Okay, however, it's still the same calculation of area, so it's multiplied by pi and multiplied by the radius squared, which is going to be 12 squared. Okay, so let's make that a little bit easier to handle. So 30 over 360 is 1/6, multiplied by pi multiplied by 144. So basically I need to know how many 6's there are in 144. Well, there's actually 24 of them, so the answer to this particular question will be 24 pi, and that's going to be centimeters squared. Okay, hopefully that's all right for you. Let's move on then to question number 9, which is equation of a straight line. So find the equation of a straight line which passes through the points 3, 2 and 6, 11. So really for the equation of a straight line, the general form is what we call y equals mx plus c. Okay, so the first thing is m is actually the gradient. Okay, now the way we work out the gradient is going to be y2 minus y1 divided by x2 minus x1. If you're not sure about any of these, please do let me know, because I have specific playlists on these types of questions. Okay, so if we go back to our coordinates, I'm going to write on my coordinate, this is y2, and therefore this is y1, x2 and x1, and then basically I can feed this information directly into my gradient calculation that y2 is going to be 11, y1 is going to equal to 2, x2 is going to equal to 6, and x1 is going to equal to 3. Okay, so therefore it means that I've got a gradient of 9 over 3, which is actually a gradient of 3. Okay, so we've got our first part correct. We've got y equals the gradient of 3x plus c, or rather a gradient of 3 plus c. Okay, so we need to then find out the value of c. Now you'll know that the value of c is where it crosses the y-axis. However, all we need to do is just choose either the coordinates 3, 2 or the coordinates 6, 11 and just basically feed them straight into this calculation in order to find out the value of c. So therefore I'm going to put at point 6, 11. Okay, so basically y equals 11 and 6 equals x. So I've got 11 equals 3 multiplied by 6 plus c. So 11 equals 18 plus c minus 18 from both sides. I'm going to get minus 7 equals c. Okay, so therefore the equation of the straight line is going to be y equals 3x minus 7, and that would be the answer to question number 9. That's worth 3 marks to you to do something like that. Okay, let's move on then to the final question on this paper, which is actually worth 5 marks in total, and it's one of those questions where we're sketching a graph and we need to work out the value of each of the values of y if we got the values of x. Okay, so the first thing I'm going to do actually is just a little bit trickier on this screen. So what I'm going to do is I'm going to work alongside here. Now what I'm referring to is this grid at the very top here, and you'll see here we've got a couple of values already. We've got 0 minus 4 and we've got 1 minus 4. That's perfectly fine. What I'm going to do is I'm going to have a look at the values of x of 2 and then 3, and then I'm going to go to the negative values. Okay, so let's work out all of these. Now remember that we've got the actual formula of the equation, which is y equals x squared minus x minus 4. Okay, so when x equals 2, I can just simply say that 2 squared minus 2 minus 4 is going to be equal to my value of y, which is going to be minus 2. Okay, so what I'll do is I'll go back to my grid and I'll write in here minus 2. Okay, let's have a look then at the value of x equals 3. So when x equals 3, I've got 3 squared minus 3 minus 4, which is going to equal to positive 2. Okay, so again, back up to my grid, I've got positive 2 in there. Okay, so now I'm going to have a look at my minus 1, minus 2 and minus 3. I tend to, if I can, deal with positive values first and then deal with the negative values afterwards. So let's have a look at x equals minus 1. Well, again, I've got minus 1 squared minus, be careful with this, minus 1 minus 4, and when I work all that out I'm going to get minus 2. So be very careful with your negative numbers. Don't forget a minus times a minus is going to be positive, and a minus minus is also going to be positive. So this is going to be a positive value and this is also going to be a positive value. So just be very careful about that. Okay, so I know that's now going to be y is going to be minus 2 when x is equal to 1. So here's minus 2 in there. Okay, and we're going to do the same for the final 2 questions. Just running out a little bit of space here, but I've got x equals minus 2. So I'm going to have minus 2 squared minus minus 2 minus 4, and all of that is going to give us a positive value of 2. And then finally I've got x equals minus 3. Okay, and I'm going to put that into the equation. I'm going to get minus 3 squared minus minus 3 minus 4, and that's going to be a value of 8. So therefore I can go back to my grid and I can write into here 2 and positive value of 8. Okay, so then it's a case of drawing the actual values on the grid. Okay, so I appreciate I'm sort of backwards and forwards a little bit with this, but hopefully it'll give you some idea. So if I start with the positive values first, I've got 0, -4, which is going to be down here, and then I've got a value of 1, -4, which is going to be here. Okay, then I've also got 2, -2, which is going to be there, and then I've got 3, 2, which is going to be over here. So that's my right hand side of the curve taken into account, at least as far as the information I've got is concerned. Okay, so let's have a look then at the next bit, which is the negative value. So I've got -1, -2, so that's going to be somewhere like that. Then I've got -2, +2, so -2, +2 is here, and then I've also got -3, 8, which is going to be around there, and that would be the answer to that particular question. So what I'm going to do is I'm just going to try to draw this in a little bit. It's a bit difficult on this, but hopefully it'll give you some idea what it'll look like. You'll notice that I've put a curve at the bottom here. Okay, I'm also going to kind of speculate that it sort of goes a bit like that as well, and that's perfectly fine. Okay, so it's the curve at the bottom that will give me then my turning point. But before I do that, it says in part C, it says use the graph to estimate the values of x when y equals 4. It's actually this top question here. Okay, so when y equals 4, what we're basically saying is that it's this line along here. So what we're looking for is for the values where the graph crosses. So it seemed to make sense for me to extrapolate my graph a little bit earlier on. Okay, so if I read that, I've got a positive value of 3.5 and I've got a negative value of -2.5. So the values of x will be that x equals -2.5 and x equals +3.5. Okay, and then the final little bit of it says use the graph to estimate the turning point. Well, the turning point is the lowest point of the graph. It's actually this one here. Now you have to remember, so it's this one. You have to remember that really what we're doing is it is a quadratic, so it's got a nice curve to it. So what you don't want at the bottom of a quadratic is going to be a flat line. It would always have a curve. Okay, so if I take the coordinates of that, it's going to be 0.5 and also -4.5, and that's this point at the very bottom of the graph there. Okay, hopefully that's okay for you. That's the end of this particular video. Please do let me know if you need any help, and I look forward to seeing you inside the next video.
Okay, so I hope the video was useful to you. Please do add a comment if you're not sure about anything, subscribe to the site, like the video, and I look forward to seeing you inside the next video.